NASA has recently made a groundbreaking revelation regarding a new planet that has captivated scientists not only due to its size and location but also because it emits lights that seem artificial. Could this discovery suggest the presence of life on other planets? Join us as we dive into NASA's extraordinary findings and uncover the truth behind these mysterious lights. In 2007, NASA launched the Dawn spacecraft with a mission to explore some of the most intriguing objects in our solar system. Equipped with 3 ion engines, Dawn was capable of an extraordinary journey. Its mission began with a 14-month study of Vesta, the second-largest asteroid in the belt, during which it sent back detailed images and data revealing Vesta's complex surface and rich geological history. After completing its primary objective at Vesta, Dawn set off on its next, more exciting phase, an in-depth investigation of the dwarf planet Ceres. Thanks to its ion engines, Dawn was able to leave Vesta's orbit and travel to Ceres, an achievement that traditional chemical propulsion would have struggled to accomplish. These engines provided a gentle but constant push, allowing Dawn to cover vast distances and settle into a stable orbit around Ceres. Discovered in 1801 by Italian astronomer Giuseppe Piazzi, Ceres is the largest object in the asteroid belt between Mars and Jupiter. For a long time, it was considered the smallest planet in the solar system until its reclassification in 2006. With a diameter of approximately 950 kilometers, Ceres is the largest and most significant body in the asteroid belt, intriguing scientists due to its unusual characteristics. As Dawn approached Ceres, researchers eagerly awaited the first detailed images of this enigmatic world. One of the most captivating features discovered was a series of bright spots scattered across its surface, most notably within a large crater now known as a Cater crater. These bright spots immediately sparked interest and speculation. Before Dawn's mission, the best image of Ceres was a fuzzy, low-resolution photograph taken by the Hubble Space Telescope. Scientists knew very little about this dwarf planet, and the possibility of finally getting a close-up view was thrilling. What secrets would Ceres reveal? What discoveries awaited? The mission promised to enhance our understanding of the solar system's evolution and the role water plays in shaping planetary bodies. The bright spots on Ceres are unlike anything seen on other asteroids. They appear to be made of highly reflective material, possibly salts left behind by sublimated water. This led to the hypothesis of cryovolcanism on Ceres, a process where water or briny liquids erupt from below the surface instead of molten rock. What could these mysterious lights be? And what do they tell us about the nature of Ceres? Could they be signs of ongoing geological activity or something even more extraordinary? Ceres stands out from other celestial bodies in the asteroid belt due to its size, mass, unique composition, and potential for water and ice. Unlike the typical rocky asteroids, Ceres has a composition more akin to a comet, suggesting it holds more secrets about the early solar system than we ever imagined. After 2 years of traveling, the Dawn spacecraft finally began its approach to Ceres in mid-2015, marking a critical milestone in the mission. For the first time, humanity would get close-up images of the largest object in the asteroid belt. As Dawn neared Ceres, the images became increasingly detailed, offering glimpses of a world previously shrouded in mystery. The first images revealed a surface marked with craters, suggesting a long history of impacts. However, it wasn't just the craters that caught the attention of scientists and space enthusiasts. The bright spots stood out against the darker, rocky terrain, sparking intense debate. Were they patches of ice reflecting sunlight, or could they be something even more exotic? Theories ranged from mineral deposits to possible signs of cryovolcanic activity. Further investigation revealed that the brightest spot was not a single entity but a cluster of several distinct spots, deepening the mystery. The theory that these were salt deposits left behind by sublimating water gained traction, suggesting that Ceres may have, or still has, some form of geological activity capable of bringing water or briny fluids to the surface. These fluids could evaporate quickly, leaving behind bright reflective deposits. These findings challenged previous ideas about Ceres, painting a picture of a more dynamic and complex world than scientists had imagined. The presence of such features hinted at the possibility of subsurface water or briny pockets, which could have significant implications for the potential for life in our solar system. But what makes Ceres so different from other planets? Often described as a frozen world with a rocky but porous surface, Ceres stands apart because of its unique composition. Its surface is a mix of water, ice, and hydrated minerals, including clays and carbonates, giving it a distinctive, less dense structure compared to its neighbors. This composition suggests that Ceres contains a large amount of water, and its surface layer, though rocky, is permeable, with ice and other volatiles trapped inside. This frosty characteristic is more typical of a comet than an ordinary asteroid, hinting at a history that might involve a blend of rocky and icy materials. Deeper beneath its surface, Ceres holds even more fascinating secrets. Scientists believe it has a differentiated interior, which could further enhance our understanding of planetary formation and the potential for water in other parts of the solar system. Ceres, a dwarf planet, has a unique internal structure comprising a slippery mantle and a dense core. The mantle is thought to be rich in water ice, making up about half of Ceres' total volume. This mantle is likely a mix of rock and briny solutions, surrounding a core that could be composed of denser materials, potentially silicates. The abundance of water ice suggests that Ceres might have once hosted liquid water, especially if its core was heated by radioactive decay early in its history. This internal composition sets Ceres apart from other asteroid belt objects and raises intriguing questions about its potential for geological activity and the role of water in its evolution. Additionally, the discovery of ammonia-rich soils on Ceres implies that the dwarf planet may have formed in the colder regions of the early solar system and migrated inward. Ammonia can lower the freezing point of water, which supports the idea of subsurface brines on Ceres. These findings not only enhance our understanding of Ceres but also offer valuable insights into the processes that govern the formation and evolution of icy bodies in the solar system. One of the most fascinating features of Ceres is its cryovolcanism, a process that contrasts with Earth's conventional volcanism. Cryovolcanoes, or ice volcanoes, release volatile substances like water, ammonia, or methane, which can exist as liquids or gases in the extremely cold conditions where these volcanoes are found. On Ceres, cryovolcanism operates by allowing briny water to reach the surface. When this salty water comes into contact with the vacuum of space, it rapidly sublimates, transforming directly from solid or liquid to gas, leaving behind bright, reflective salt deposits. These salt deposits, especially those seen in a crater, create the striking bright spots on Ceres' surface. These bright spots have attracted significant attention due to their high reflectivity and the occasional presence of clouds, believed to be caused by the sublimation of water. This suggests that cryovolcanic activity might still be ongoing or recently occurred. In addition to the bright spots in a crater, Ceres has several others scattered across its surface, indicating that cryovolcanism could be widespread. The presence of these bright spots challenges previous assumptions that Ceres was a dead, inactive world. As NASA's Dawn spacecraft provided clearer images of Ceres, a wealth of surface features became visible. The dwarf planet's surface is pocked with various craters, each telling a story of Ceres' history. Some craters are relatively shallow and eroded, indicating an ancient surface exposed to numerous impacts over billions of years. Others are better preserved, with sharp edges and deep bowls, suggesting more recent impacts. Interestingly, there are fewer craters on Ceres than initially expected, hinting at geological processes that may renew the surface and erase evidence of older impacts. One hypothesis is that Ceres' icy crust allows for cryovolcanic resurfacing, where subsurface materials periodically well up and cover older features. This dynamic process indicates that Ceres is not a static world but one that has, and potentially still is, undergoing significant changes. Further evidence of geological activity on Ceres comes from the observation of cracks, grooves, and mountain ranges on its surface. These features show that Ceres has experienced considerable stress and deformation. Some of these cracks appear relatively young, possibly just a few 100 million years old, suggesting ongoing surface activity. The grooves and ridges may have formed as the surface was stretched and pulled apart, while mountain ranges and compressional ridges indicate areas where the crust was squeezed together. These contrasting surface features offer a glimpse into the complex processes that have shaped Ceres over time. One particularly interesting feature is a large dome-shaped mountain within one of the craters, potentially linked to internal pressure or upwelling materials associated with cryovolcanism. Together with the extensive network of cracks and ridges, this points to a dynamic and evolving surface. Dawn's observations have also revealed intriguing surface compositions. Beyond the bright spots and reflective salts, NASA's data has uncovered a variety of materials that are important for understanding Ceres' geological history. Some regions show dark, fine-grained materials that stand out from the bright salt deposits. This darker material is thought to be a type of carbon-rich substance, possibly organic compounds, adding another layer of complexity to Ceres' composition and raising the possibility of prebiotic chemistry. The detection of organic molecules on Ceres has generated significant interest in astrobiology. These carbon-rich compounds are considered the building blocks of life as we know it. The presence of such molecules on Ceres opens up exciting possibilities about the potential for life, or at least the building blocks for life, to exist or have existed on this dwarf planet. Another striking feature of Ceres is the large number of dome-shaped structures, some reaching heights of up to 6 kilometers. These domes are thought to be the result of subsurface processes pushing material upwards through the crust. Their shapes and sizes suggest that they may have formed from cryovolcanic activity or internal pressure driving materials upwards. Understanding these features is key to unraveling the geological history of Ceres and its internal structure. Furthermore, gravity data gathered by Dawn has provided insights into the distribution of density within Ceres. Variations in gravity indicate the presence of distinct layers inside the dwarf planet, potentially including a subsurface ocean or briny pockets. These findings are crucial for understanding Ceres' thermal history and its potential to harbor conditions suitable for life. Overall, the Dawn mission has significantly expanded our knowledge of Ceres and reshaped our understanding of small celestial bodies in the solar system. As more data is analyzed, scientists hope to further uncover the mysteries of this intriguing world and explore its potential to reveal insights into the broader processes that govern planetary formation and evolution.